Welcome Algebra 2s. Now we're going on to lesson 4 and we're actually going to do something with adding, subtracting, multiplying, dividing, all those rational expressions, and we will solve them. That's the purpose of the whole thing, to start solving some of these complicated pieces. Alright, and as we go and solve these now, we're actually going to take a look at two different methods, so I'm going to keep showing you them a little bit. So you can see the two pieces. The first here, of course, is to equate the numerators. Alright, what that means is I want to get a common denominator. And if you look at 2, 3, and 6, you should recognize that the common denominator is going to be 6. So I get a common denominator of 6, so I'm going to put them all over 6. Got our equal signs here. Now, obviously, the 5 is already over 6, so there's no need to change it. How do I go from 3 here to 6? Well, of course, I multiply by 2. So if I multiply by 2, that means the top turns out to be 2. Then I get a plus sign here. What times 2 gives me 6? Of course, a 3. So I multiply the top by that 3. Because all I'm doing is multiplying by 1 and making them look different. And I get a 3x. Once I do that with that method, I'm ready to start combining here. So I get a 3x plus 2. And combine these two on the left side, all over 6, equals the right side, 5 over 6. Okay. If I have a common denominator on both sides, all I have to do is set the tops equal to each other. So therefore, I get 3x plus 2 equals 5. And then from there, all I got to do is do my normal basic algebra, which you guys love, piece of cake, 3x equals 3. Divide by 3, and the answer is x turns out to be 1. Okay? Then you can turn around and you can verify that. If I do that, once again, verifying means a check. And if I do that, I'm going to put a 1 in for x, so 1 over 2 plus 1 over 3. Does that equal 5, 6? And if you have to, use your calculator. 1 divided by 2 plus 1 divided by 3. And don't forget, math num 9. Okay, so math num, nope, my bad. It's math enter enter on the calculator. Thinking the wrong thing here. So math enter enter. When you add the 1/3 and the 1/2 and 2/3, and you will get 5, 6 equals 5, 6. So we've got the check. We know it works. All right, let's look at another method. The same problem. Alright, the second method is clearing fractions, and personally this is my favorite. Same type of scenario, you got to look at it, and you look at these three right here, and you say, hey, the common denominator is 6. So all I do is multiply everybody through by a 6. 6 in the top, 6 in the top, 6 in the top. What happens is 2 goes into 6 3 times, so I'm left with 3 times the x. The 3 goes into 6 twice, so I'm left with the 2. And that equals, the 6 cancels with the 6, the 5. And you're off and running again, bring the 2 over, so you get 3x equals 3, and x is 1, and you can check it. Okay. Same thing, I just multiply everybody through by the common denominator, I divide out by the bottoms, and we're off and running. And I love that method, but it is totally up to you what you choose. Alright, next example. Alright, so I've jumped down to example 3a, skip number 2. We're going to do that in class, though, too, just for some of the people. We'll get there. Same situation. You've got to get a common denominator. The common denominator between 12 and 6, of course. Both go into 12. So I will set them up as 12s. Obviously, the left side is already over 12, so I put the x plus 3 there. How do I go from 6 to 12? Well, I, of course, multiply by 2. Multiply the bottom by 2 to get 12. I got to multiply the top, so I get 10. Now that you got equations that are equal with denominators are the same, you can set the tops equal to each other. So x plus 3 equals 10. Move the 3 over, move the 3 over. X equals 7. So there's my answer, my solution. Then you do the check again. If I do the check, I get 7 plus 3 over 12. Does that equal 5 over 6? So I get 10 over 12. Does that equal 5 over 6? That's the question. And of course, if you reduce that, or you throw it in the calculator and do math, enter, enter, you will get 5, 6 equals 5, 6. And yes, indeed, the check does work. Okay, once again, that's called equating the numerators, getting the common denominator on there on the bottom and then you run with it. Just set the tops equal to each other. Alright, the same one with clearing the fractions. Again, common denominator is 12, so I will multiply that by 12. I will multiply the side by 12. Over here, the 12s cancel. I'm left with x plus 3. On this one, the 6 goes into 12 twice, which means 2 times 5 is 10. Move my 3 over real quick, and x turns out to be equal to 7. And we've already checked it, so we know it works. That's clearing the fractions. Like I said, my favorite choice. Alright, so for my last example here on the video, we're going to get harder. And of course, this is not so easy to look at what the common denominator is. And we had practice of all this when we were adding and subtracting. So the bottom line, when I take a look at it, I can't do anything with a plus 2. That's part of my common denominator. I can't do anything with a minus 2. That's part of my common denominator. And I need to factor this thing. So you should recognize the dot sitting there. So that is an a plus 2 times an a minus 2. Okay? So if that's the case, every time we're going to be multiplying by a plus 2 if you use my method, the clearing, and a minus 2. This one would be an a plus 2 times an a minus 2. And an a plus 2 times an a minus 2. So, the first one, I'll use a different color. The a plus 2 cancels with the a plus 2. So what am I left with? I'm left with this a minus 2 times 1. Well, anything in 1 is itself, so that's going to be an a minus 2. Plus, there's our plus sign there. The next one, a minus 2's cancel. So what am I left with? 1 times a plus 2. So that's an a plus 2. Equals. On this side, I got an a plus 2 cancels, a minus 2 cancels, so I'm not multiplying by anything other than an unwritten 1. And of course, 1 times 4 is 4. Clean the things up. I've got a and a make 2a. Minus 2 and plus 2 is gone, so 2a is all that's left on the left, equals 4. Divide by 2, and a turns out to be 2. And if I check it, the thing will work, because I actually get 1 over, if I do the check, that's my answer, I get 1 over 2 plus 2, plus 1 over 2 minus 2, equals 4 over 2 squared minus 4. So if I start checking, this is the reason why we're checking it, my bad, I'm telling you that it works. I get 1/4, okay, plus 1 over 0 equals equals 4 over 0. We ran into a problem here, didn't we? Am I allowed to divide by 0? No. So, actually, a turns out to not work. So, we have no real solution here out of this whole thing. Because if you remember back to the bottom, a can't equal a negative 2. If I put it in, it makes it 0. A can't equal a positive 2. And in this one, when I solve, it can't be either one. Any of those things makes it equal to 0. So we actually have no solution in this one. It's not even no real solution. I can actually just say no solution. There is no such answer that works for this problem. So we're going to talk more about that in class. Thanks for watching, and I'll catch you tomorrow in class.